Hello and welcome to this presentation related to an overview of quantitative and qualitative data. The object of this presentation is to provide underpinning knowledge to help you attempt an assessment in which you have to both examine and analyse various quantitative and qualitative data. So a quantitative question that might be posed to students is, what do you think of your engineering studies at college? And you may provide them with one of 5 options from which they can choose the appropriate response. And then you can analyse such data and display this information in pie chart format, which is a very visual and common method of displaying such quantitative data. A follow-up qualitative question might be, why did you make the above response? To which the student then can provide an open response. The various qualitative responses can then be collated and they can be analysed using the appropriate methods we'll outline later in this presentation. Here's a presentation overview. The presentation is essentially split into 3 sections. The first section is a recap of quantitative data, that's data expressed in numerical form. At this stage of their studies, engineering technician students are quite familiar with quantitative data, so this section purely recaps for them the use of tally charts, calculating central tendencies such as mean, mode and median, calculating dispersions such as the range or a standard deviation, how that relates to a normal distribution, the use of pictographs, pie charts, bar charts and histograms. Section 1 ends with a brief introduction to qualitative data. That's data in descriptive form. Such data relates to textual information that could be obtained from an interview and thus text extracted from the resulting interview transcript. Section 2 considers quantitative data in slightly more depth. We initially define discrete and continuous data collection. We introduce the use of Likert scales, often used in quantitative data gathering, where a specified range of responses are given to a participant related to a question or scenario posed. There's an extract of what's termed the Job Diagnostic Survey, the JDS. This is a standard quantitative research tool that's used to calculate the motivating potential scores, MPSs, of workers working in various sectors of business and industry. This illustration tries to show you how, using a workforce survey, quantitative data can be gathered, in which we can calculate the MPS values to try and determine the motivation of a particular workforce. The extracts shown here were actually part of a formal report submitted to senior management for their reference. In section 3, we now consider qualitative data in more depth. We first of all outline some data gathering techniques used to obtain qualitative data, such as surveys, interviews, etc. We consider the analysing of qualitative data using what's termed a coding schedule. There are many different forms of coding schedule available. We outline 2 coding schedules here. And coding schedules are used to aid generation of themes that we try and extract from qualitative data. As stated above, quantitative data results are often stated in statistical form, mean, modes, median, standard deviation, etc. But the findings and conclusions from qualitative data often relate to patterns or themes that evolve from analysis of the data collected. To try and highlight the use of coding and themes, a journal article illustration is included that shows the codes that we use when analysing the qualitative data collected and how themes were then generated from the codes. From my experience of working with technician engineers, when they are first exposed to qualitative data, they tend to think it's easier to analyse than quantitative data as it's less mathematical. I would contend that qualitative data is at least, if not more difficult to analyse than quantitative data, because often in the situational context that the participants are exposed or engaged often has significant influence on perceptions and attitudes of participants. As the saying goes, just because a participant says it's so and doesn't make it so. As a qualitative researcher, I have to look behind what's said and clearly ground our analysis, avoiding subjectivity and hopefully producing objectivity in the way we generate our themes and our findings from qualitative data. Hopefully this presentation will provide an insight and a foundation on which you can undertake your own research and develop your own understanding into quantitative and qualitative data. And for your reference, here are the approximate start times related to Section 1, Section 2 and Section 3, hopefully to aid your ease of access through the presentation. Let's initially consider a brief overview of quantitative and qualitative data. So scientific investigations can generate large amounts of what's termed raw data. Such data requires analysis to help derive meaning and so develop understanding. Scientists and engineers often use a range of tools, including tabulation, graphical interpretation, statistical analysis, etc., to aid interpretation and identify significant patterns, trends, or themes occurring in data collected. Such methods used, as I know you're familiar with, as we considered previously in our mathematics presentations, tally charts, having categories and collating the frequencies related to each category. The context of the tally chart relates to the measurement of bars, no doubt produced from a production line. And then we can use charts or graphs to display various information. In this particular chart here, we have strengths of load-carrying bricks on the horizontal axis, and we plot the frequency related to various categories of strengths on the vertical axis. These are methods I know that you're familiar with and used in other topic areas. Computers can aid the collating of large quantities of data, for example using spreadsheets or specialist design packages. And these can analyse both numbers and text, descriptive data. In quantitative studies, the interpretation and analysis may involve calculating statistical values such as the mean, the mode, the median, the dispersion, that's the spread of data, and use of tally charts, pie charts, histograms, etc. to both display the raw data and also to help analyse and present the findings. Here are some quantitative statistical methods. Again, I'm sure you'll be very familiar with these various quantities. Calculating the arithmetic mean, often denoted as x bar. Calculating the median, finding the mode. Those all relate to central tendencies. Determining the range of the data. The range is the largest value minus the smallest value in our data. And a more advanced calculation for determining dispersion is to calculate the standard deviation, usually symbol sigma. Values of sigma relate to the normal distribution. And here's a recap slide related to arithmetic mean, denoted as x bar. Definition of the mode, the median, and the range. Here's the standard deviation, usually denoted by lowercase sigma. This formula shown here is usually undertaken in terms of a tabular approach. This is an extract from a previous presentation showing a calculation for sigma here. Recap of normal distribution, typically a bell-shaped curve. And the spread or the dispersion is related to the standard deviation. There are separate presentations that outline in much more detail the calculation of central tendencies, standard deviation, and application of the normal distribution. So analysing and interpreting quantitative and qualitative data. Let's consider quantitative data, some graphical methods. This slide shows pictographs. The left-hand diagram relates to historical production output of bicycles from a particular company. The categories used here are 1970 through to 1974. And notice that each of the symbols, in this case a bicycle, relates to 2,000 bikes produced. So in 1970 we would state that from the pictograph 2,000 bikes were produced. In 1971 we would state that 4,000 bikes were produced. 1972, we would estimate from the pictograph that 7,000 bytes were produced. But that's an estimate because we're not sure whether that was 7,400, 7,600. Very difficult to assess the actual value from a pictograph, but nevertheless, the pictograph displays the production output in relatively easy to understand form. The right-hand pictograph relates to motorcycle accidents, and on the vertical axis states the object hit by the motorcycle. So we have categories here such as car, pedestrian, property, cyclist, and so on. And notice that each of the images relates to 3%. So if we consider the cyclist, for example, we have 1, 2, 3, 4, 5 cyclist symbols. So that would equate to 15% of the accidents considered in this particular time period were motorcyclists colliding with cyclists. And notice they've stated the 15% numerical value on the right hand side in what's shown as a percentage column. And it's actually quite useful to have the right hand side column stating the actual values, because if we now consider the bus category, it's not easy to determine what the percentage is. My estimate there would be 4.5%, because it looks like I have half of a bus, but the actual value is stated as 4%. And the same with the horse-drawn vehicle category. Quite difficult to assess the quantity there. We look like we have the cart but no horse. So we have half of the symbol. So that would be half of 3%, so 1.5%. But essentially, pictographs, graphical methods for illustrating quantitative data collected. Quantitative data continued. Pie charts are often used to display quantitative data. This particular pie chart relates to research in manufacturing and shows the breakdown of manufacturing in various industries. So in other words, the research in this particular time period in the electrical industries is shown by this sector of the pie chart, but most manufacturing research, it would appear, occurs in the aircraft sector. So visually we can see that's the case because it's got the largest sector of a pie chart, but note again the actual percentage values of research in the various sectors are also stated. So the visualization of the pie chart instantly shows you where most of the research in manufacturing occurs, but if you want the specific values, then the pie chart also states these. So again, a very useful way of displaying quantitative data. Quantitative data continued here with some bar charts. Again, these relate to more so historical information. On the left-hand side, we have average earnings of engineers from 1992 to 1999. These data relates to technician engineers, incorporated engineers, and chartered engineers. And also we have a bar chart relating to median earnings. This is between 1995 and 1999, again for the same categories of engineers. So on the horizontal axis we have the various categories, and on the vertical axis we have the salaries. And as these relate to the United Kingdom, then the values are in terms of pounds. So again, bar charts, useful way of displaying quantitative data. Quantitative data continued. Here we have a histogram. I've extracted this slide from a previous presentation related to statistical analysis. This histogram relates to a sample of metal components whose lengths were measured from the production line. The histogram is shown by the dashed lines here. Histograms relate to continuous data. Just highlighted the histogram for ease of reference. As I say, we've reviewed histograms and their construction in previous presentations. So for quantitative data, sources of error can be identified and often the degree of certainty can be determined using probabilities, confidence levels, etc. Engineers analyse data collected in experiments or tests of their research, designs, and scientific or mathematical analyses. And this research usually involves quantitative data collection. The collection of such data allows for a comparison between the different designs or analytical solutions proposed and so the engineer can determine how well each design or solution meets the specific design criteria. For example, which solution or analysis is the optimum to solve the problem under review within the stated constraints. And within engineering, such constraints may include cost, project timescales, resources available, experience, expertise, etc. However, sometimes engineers undertake qualitative studies, and these involve the use of textual data, for example, data extracted from interviews that have been transcribed, often termed interview transcripts. So such data have to be analysed using what's termed non-numerical methods, such as reviewing data for themes or patterns. As a note of reference, it's quite interesting that former HND students, when choosing their research projects, often prefer to undertake qualitative studies as opposed to quantitative studies, even though their engineering background is more related to collecting quantitative data as opposed to qualitative data. And just for your interest, here are some of the research projects that past students have undertaken. I'll let you read these project titles at your own pace, but they all involved collecting qualitative data by the use of questionnaires, one-to-one interviewing, etc. So in essence, when data are collected, they are commonly considered to be in one of two categories, either quantitative or qualitative. And just note as a point of interest, the word data is actually plural. So within academic literature, the following statements are more likely to be found. These data were collected from a workshop experiment. After the experiment, the raw data were uploaded to the website. In general parlance, you often hear people state the data, but to be academically correct, we should state these data. And particularly in academic literature, you will note that data is considered plural. Okay, in this section, we're going to consider quantitative data in greater detail. And remember, quantitative data is stated in numerical form. Quantitative data overview. Typically, quantitative data involves counts or measures and are expressed numerically. For example, quantitative data involves counting how many, how much, how often, etc. Quantitative data can be considered as discrete. For example, the number of cars in a showroom, shoes that are sold in defined sizes such as 6.5, 7, 7.5, 8, etc. and the number of defective items produced from a production line. Or quantitative data can be considered continuous. In other words, heights of buildings in a survey, lengths of machine components that have any value between the lower and upper tolerance. So in essence, discrete data are counted, continuous data are measured. As previously stated, standard statistical methods are used when collating, analysing, and presenting quantitative data, such as pie charts, bar charts, pictograms, histograms, frequency curves, etc. And we can also describe quantitative data in terms of central tendencies, such as the arithmetic mean, the mode, and the median. We can also calculate the dispersion, that's usually in the form of the range and standard deviation. The latter is particularly used for large quantities of data. Scientific calculators have built-in statistical functions, and there are computer software packages such as spreadsheets that can easily sort data and display data in various graphical forms. Quantitative data overview continued. Where appropriate, researchers often try to use a structured approach to obtaining participants' opinions. For example, using Likert scales. A Likert scale is a type of rating scale used to measure opinions or attitudes or behaviours, and with such scales, participants are requested to rate statements or questions that are listed on a survey to a level of agreement. So typically, 5 to 7 categories of response offered within a statement or question on a survey. For example, the level of agreement offered could range from strongly agree, to being neutral, to disagree, or strongly disagree with the question or statement posed. If the above Likert scale is combined with a free response option, for example, after the participant has decided on their level of agreement, a question could be added to please state the reason for your choice, as this has the potential to provide a mixture of both quantitative, i.e. the level of agreement stated, and also provide for qualitative data, in other words, richer data that then starts to explain the reason why the level of agreement was chosen. So, for example, the number of people selecting a particular category or level of response may ultimately be stated as 75% of the workforce responded agree to enjoying their work. This is quantitative, whereas a written free response would be work has lots of variety, which is considered qualitative, and again helps to provide insight as to why the level of agreement was chosen. Quantitative data overview continued. Here's an illustration of a survey I undertook many years ago within an engineering company. This was a standard questionnaire entitled the Job Diagnostic Survey, and it was developed by researchers Hackman and Oldham, who were university researchers who undertook research related to the study of jobs as found in the workplace. I used this questionnaire to try and determine the motivational characteristics within an engineering company. So essentially the questionnaire helps determine how people react to different kinds of jobs, and in my research it was used to study the motivational state of the current workforce. The questionnaire essentially consisted of 5 questions that workers were asked to respond to related to their job. The questions were designed to obtain the workers' perceptions of their jobs and their reactions to it. Again, a Likert scale was used with responses from 1 to 7, and the workers were asked to place a circle around one of these responses to show their level of agreement. The Job Diagnostic Survey continued. I've just extracted 2 questions from the survey to illustrate the format of the survey. Question 1 asks the worker how much variety there is in their job they do. The question was related to what's termed skill variety within the job, and the Likert scale has levels of agreement from 1 through to 7. Response to the question how much variety is there in your job, the left hand end states very little. The job requires me to do the same routine things over and over again. That ranges right the way through to level 7, where the response to how much variety is there in your job becomes very much. The job requires me to do many different things using a number of different skills and talents. So the employee is asked to circle the response that they deem most appropriate related to their perception of their job. And question 2, to what extent does your job involve you doing a whole or identifiable piece of work? This was termed by the researchers as task identity. And again, the response is from 1 through to 7. And the workers are required to state their level of agreement with the question. So this is an illustration of how a survey can be used to collect quantitative data for research purposes. Job diagnostic survey continued. So from the data collected, it was possible to determine a motivating potential score, MPS, that's evaluated from the job holders or the workers' responses to 5 questions that were posed. The MPS was evaluated as per equation 7.1, shown here. This equation has been extracted from the report produced, so the MPS is calculated from the equation shown here. Below I've just showed you the results for one department within the engineering organisation, and their mean average MPS value for all the workers in that department was actually 62. This value was then related to Hackman and Oldham's typical MPS scores for different industries and different jobs to determine whether the workers in this survey were considered to be highly motivated or not in their particular job roles. Here are the various values calculated from the results of the questionnaire for all employees within this particular department. So these are the mean values calculated. Obviously, without more information, you cannot really understand the full picture of what's been researched here. But from the point of view of this presentation, this shows quantitative data in action, where a questionnaire has been used and quantitative responses have been given. So for each of the particular questions, we can work out the average response for the workers, and we can then calculate what's termed the motivating potential score. In practice, once the quantitative data has been gathered, I then look for particular trends within the data, considering very low motivating potential scores and very high motivating potential scores. And then I specifically had short interviews with particular workers from the various departments that exhibited these disparities in MPS scores to try and obtain some qualitative data to enrich my analysis and then explain why certain workers were disaffected with their jobs and unmotivated, and some workers were highly enthusiastic and highly motivated about their jobs. In this part of the presentation, we're now going to consider qualitative data in more detail, and this relates to the descriptive form of data. You'll see I spend more time and go into slightly more depth in the explanation of qualitative data, mainly because at this stage of a technician engineer study, they often have been exposed to quantitative data, but have not really considered qualitative data. Some students think qualitative data is much easier to analyse than quantitative data because it requires less mathematical knowledge. But from my experience of undertaking qualitative research, qualitative data can actually be considered quite messy to analyse, and if you're not careful, can be quite subjective. And one of the main essence of research is always to be objective in your collection and analysis of your data. So often researchers themselves have to consider their influence on the way they collected and analysed data, because we all have inherent biases that we may or may not be aware of, and these can impact the validity of the collection and analysis of data. So you'll see in the following discussion, I spend quite some time outlining what are termed coding frameworks or coding schemes. But in qualitative data, we often use such schemes to try and focus on generating themes from our data. And by doing so, we justify the themes that we have derived, and therefore the findings and conclusions we're drawing from our data. And that's a very important aspect of engaging with qualitative data. So qualitative data, an overview. So qualitative data are typically collected in descriptive form. That's textual form as opposed to numerical form. Example of collection methods includes diary entries, open-ended questionnaires, focus groups, unstructured or semi-structured interviews, and observations. Qualitative data tends to be richer than quantitative data, and so can provide insights, justification, understanding, etc. to quantitative data obtained. As I said from the previous section, we used a survey to determine motivating potential scores of workers, and this informed us if the worker was highly motivated or not, but where disparities in the quantitative data occurred, for example, in a department there could be extremely low and extremely high motivated potential scores, use of one-to-one semi-structured interviews helped to dig deeper in understanding why these significant variations in motivational scores occurred. And some reasons that transpired from the interviews included lack of appreciation and recognition from management for particular work undertaken, favoritism that was occurring within the workplace, and lack of communications within and between departments. So such concerns raised from the qualitative interviews could now add to the findings from the research and themselves be a source of further research. Let's consider briefly qualitative research methods, the method and the purpose listed in the table here. So firstly, let's consider the survey. This is used to understand general characteristics of a population, and the surveys can relate to self-completion questionnaires. The interview is used to gain more in-depth understanding of a topic using a one-to-one format. Interviews can be structured in that exactly the same questions are asked to all the interviewees or participants. But this rigid approach does mean the questions have to be very clearly thought through prior to the interview to ensure that the responses from the interviewees and thus the data gathered will specifically answer the study's research questions, as no deviation from the questions is allowed with structured interviews. Interviews can be semi-structured in that again there is a list of questions that are posed to the interviewees, but some allowance for digression around the topic area is permitted, and thus semi-structured interviews can capture slightly wider and richer data. But this slight lack of rigidity in the actual undertaking of the interview can slightly hamper the analysis of data. And finally, unstructured interviews. These personally I would tend to avoid, because although they allow the participant to talk very generally about a particular topic area that is under consideration, the analysis of such interview transcripts can be rather time-consuming and quite difficult. And indeed, the data gathered may be too general to answer the specific research questions posed. Focus groups. These are used to gain more in-depth understanding of a topic area, but this time using a group format. The vignette. These are used to elicit perceptions, opinions, beliefs, attitudes from participants' responses or comments to stories or questions that are posed to them that depict various scenarios or situations. The responses of the participants are usually summarized in an essay format and then offered to the participant for check-in. Diary entries. These are used to provide self-reporting and what's termed a longitudinal record, so over a period of time, of a user's behaviors and attitudes, which researchers can later review and analyze to better understand habits and patterns that have occurred. And finally on this listing is observation. This is used to understand how something occurs in its natural setting. That's a very brief overview of various methods used in qualitative research for data gathering purposes. You can now, if you wish, research these in greater detail and indeed consider other methods used within qualitative research. Qualitative data overview continued. Let's consider coding and analysing qualitative data. I think sometimes people assume that qualitative data is easier to analyse than quantitative data, as it doesn't require such mathematical techniques. Certainly from my experience, qualitative data is actually very difficult to analyse and actually is very time consuming to try and develop patterns or themes from the data, particularly interview type data. So we often need to use what's termed coding to help us analyse qualitative data. So in analysing and presenting qualitative data, a key requirement is to represent the material in a balanced and rational way. All researchers have to be very objective with the way they analyse and rationalise their data. So researchers should not select only examples answers or quotes that support their view of the research questions. And one way to prevent this bias tendency is to code data. To do this, researchers need to identify what's termed themes or patterns before they begin and allocate a code to each. Maybe the themes or patterns arise from a literature review that's been undertaken. As researchers continue to process their data, often further themes, patterns, and behaviours may become apparent, and similarly we assign a code to these as they arise. Qualitative data overview continued. Here's some examples of studies where coding can be a valuable technique. So coding can be very valuable across many diverse investigations. For example, recording a patient's behaviour during a hospital visit or examination, describing students' perceptions of their college studies from their reflections on their study, assessing the impact of leadership and motivational traits of line management have on workers within an engineering organisation. Qualitative data overview continued. Here's some definitions. So themes, these are aspects of the participants' accounts which characterise particular perceptions and or experiences the researcher considers relevant to the research questions. Just note that within qualitative orientated work, the study is usually founded on one or more research questions that have evolved or been generated from a particular problem that needs to be solved or needs to be understood, and usually after a preliminary literature review and possibly even some initial data collection, the research questions are formed, on which the qualitative study is then undertaken, commencing with a rigorous literature review related to the body of knowledge considered, from which appropriate data collection is undertaken, and an analysis performed, from which findings are generated that hopefully answer the research questions. And within qualitative work, the themes that evolve can underpin the findings of the study. Codes. Codes are used to aid the process of identifying themes in participants' accounts by attaching labels, essentially the codes, to help index or categorize the themes. There are many proposed coding schemes available in the literature related to data analysis and what can be coded. Table 1 shows you one such scheme and what can be coded. I'll just highlight the various entities in the table and I'll let you review them in more detail at your leisure. But firstly, specific acts and behaviours can be coded. 2, events, brief one-off events or things that people have done. 3, activities. 4, strategies, practices or tactics. The participants aim towards some particular objective or goal. 5, what are termed states. These are general conditions experienced by people or found within organisations. 6, meanings. A fact or a situation that's observed that helps explain an occurrence. 7, participation, people's involvement or adaptation to particular settings. 8, relationships or interactions between people, for example within an organisation. 9 is conditions or constraints. Conditions relate to the precursor to or the cause of events or actions. Constraints relates to things that restrict behaviour or actions. 10, consequences. What happens if something occurs. 11, settings. The entire contents of which the events are considered are researched. And 12, reflective. Within qualitative work, often the researcher's role in the process has to be considered because the researcher is an integral part of the process, e.g. the interviewer. So what's the effect of the interviewer when generating data from the interview? Qualitative data overview continued. Here's another proposed coding scheme I'll let you review this one at your own pace. Table 2 outlines the various considerations that can be coded. Qualitative data overview continued. Here's a brief illustration of themes in coding for an article I was involved with developing a few years ago. It was related to determining how well vocational qualifications help prepare technician engineering students for undergraduate study. So college technician engineering students having studied level 3 and level 4 type qualifications. Here are some of the themes that evolved from the study related to the technician student's progression to university. First, the environmental factors arose from the data, such as the location of the university study, the conditions in culture associated with the university, what was termed a situational theme related to the educational circumstances and surroundings the students were engaged with. There was clearly an assessment gap between college and undergraduate study that arose as a prominent theme, and also how the micro level of college assessment practice impacted students' preparedness for undergraduate study. So those were some salient themes that evolved from the analysis of the data gathered, and the codings used to generate the themes related to the local context of both college and university, students' perspective on easier routes to university, relationship factors with college and university lecturers, preparedness for the university's engineering mathematics study and lectures, different methods of assessment between college and university, the standard of college BTEC assessments related to level, coverage and rigour of the assessments, the university's testing culture and lack of revision and exam techniques of the students, the use of formative feedback at college and university, and the literal marking used at college compared to the numerical marking used at university. So those were the codes that I tried to use when analysing nearly 300 pages of transcribed interviews. And here's the bibliography used to help generate the presentation. I hope this presentation has given you some grounding on which you can now undertake your own research into quantitative and qualitative data. Thank you for viewing.